Ceres HOPE probe, launched in 2020, continued to study the Martian atmosphere, providing valuable data on the planet's climate. In 2024, NASA's Lucy mission was scheduled to launch, aiming to explore the Trojan asteroids orbiting near Jupiter. Advances in artificial intelligence enabled autonomous navigation and decision-making for spacecraft, reducing reliance on ground control. NASA's Parker Solar Probe continued its close study of the Sun, providing unprecedented insights into solar activity and space weather. Small satellites, known as CubeSats, became increasingly popular for scientific research, Earth observation, and technology demonstrations. In 2024, the first commercial missions to the Moon were planned, marking a new era of lunar exploration driven by private industry. The global space industry continued to grow, driven by investments from governments, corporations, and private individuals. Space tourism companies like Virgin Galactic and Blue Origin conducted test flights with the aim of offering commercial suborbital flights to paying customers. The concept of space sustainability gained prominence, with efforts to mitigate space debris and reduce the environmental impact of space activities. NASA's Europa Clipper mission, set to launch in the mid-2020s, aimed to study Jupiter's moon Europa for signs of habitability. In 2024, the first mission to explore the interstellar object Oumuamua was proposed, aiming to unlock the mysteries of these elusive visitors from beyond the solar system. The Artemis Accords, a set of principles for international cooperation in space exploration, continue to garner support from spacefaring nations. China's Tiangong space station, scheduled for completion by 2022, became operational, offering a new platform for scientific research and international collaboration. The concept of space mining gained traction, with companies exploring the possibility of extracting resources such as water and precious metals from asteroids and the Moon. NASA's Dragonfly mission, scheduled to launch in the mid-2020s, aimed to explore Saturn's moon Titan with a drone-like rotorcraft. Advances in propulsion technology, such as ion thrusters and solar cells, promise faster and more efficient travel within the solar system. The search for extraterrestrial life continued, with missions targeting potentially habitable worlds within our solar system and beyond. In 2024, NASA's Lunar Gateway project progressed, aiming to establish a space station in lunar orbit to support future lunar missions. The commercial space industry saw increased competition and collaboration, driving innovation and lowering the cost of access to space. In 2024, the first all-civilian mission to space was launched, marking a significant milestone in the democratization of space exploration. The development of in-situ resource utilization ISRO technology enabled astronauts to produce fuel, oxygen, and other essentials from local resources on planetary surfaces. Space agencies collaborated on projects such as the Asteroid Impact and Deflection Assessment (AIDA) mission, aiming to test techniques for deflecting potentially hazardous asteroids. Advances in virtual reality and telepresence technology enabled scientists and engineers to remotely operate rovers and spacecraft in real time. The concept of space habitats gained traction, with plans for permanent human settlements on the Moon, Mars, and beyond. The Artemis program prioritized diversity and inclusion, with plans to send the first woman and the next man to the lunar surface. In 2024, the first commercial missions to Mars were proposed, aiming to establish habitats and infrastructure for future colonization efforts. The exploration of icy moons, such as Enceladus and Europa, continued, driven by the search for subsurface oceans and potential habitats for life. Advances in exoplanet research led to the discovery of potentially habitable worlds orbiting distant stars, fueling speculation about the existence of alien life. The role of international partnerships in space exploration grew, with projects like the Lunar Gateway and the ISS serving as models for collaboration. In 2024, NASA's Psyche mission was scheduled to launch, aiming to study the metallic asteroid Psyche and unlock secrets about the early solar system. The field of astrobiology saw significant advances, with researchers studying extremophiles on Earth to understand the potential for life in extreme environments elsewhere in the universe. In 2024, the first crewed missions to near-Earth asteroids were proposed, aiming to study these ancient remnants of the early solar system up close. Advances in space medicine enabled astronauts to stay healthy during long-duration space missions, paving the way for future missions to Mars and beyond. The concept of space tourism extended beyond Earth orbit, with companies exploring the possibility of offering trips to destinations such as the Moon and space hotels in low Earth orbit. In 2024, the first commercial space stations were proposed, offering opportunities for scientific research, manufacturing, and tourism in microgravity. The field of planetary defense saw increased attention, with efforts to develop technologies for deflecting or mitigating the impact of near-Earth objects. In 2024, the first missions to study the atmosphere and surface of Venus in decades were proposed, aiming to unlock the mysteries of Earth's sister planets. The development of reusable launch vehicles, such as SpaceX's Falcon 9 and Falcon Heavy, revolutionized access to space and reduced the cost of launching payloads into orbit. In 2024, the first missions to explore the outer planets Uranus and Neptune were proposed, aiming to study these distant worlds up close for the first time. Advances in robotics enabled autonomous exploration of planetary surfaces, with rovers and landers conducting scientific experiments and surveying terrain. The concept of space elevators gained traction, with researchers exploring the possibility of building tethered structures to transport payloads between Earth and space. In 2024, the first missions to study the icy dwarf planets of the outer solar system were proposed, aiming to unravel the mysteries of these distant and enigmatic worlds. The field of space archaeology saw significant advances, with researchers using satellite imagery and remote sensing technology to discover ancient ruins and artifacts on Earth and other celestial bodies. In 2024, the first missions to study the interior structure of Mars were proposed, aiming to understand the planet's geology and seismic activity. Advances in space propulsion enabled faster travel between planets and solar systems, with concepts such as warp drives and antimatter propulsion becoming the focus of research. In 2024, the first missions to study the geology and potential for resource extraction on the Moon's poles were proposed, aiming to unlock the Moon's potential as a stepping stone for human exploration of the solar system. The concept of space-based solar power gained traction, with proposals to build orbiting solar arrays that could beam energy back to Earth. In 2024, the first missions to study the subsurface oceans of ocean worlds, such as Europa and Enceladus, were proposed, aiming to search for signs of life in these alien environments. Advances in artificial intelligence enabled autonomous spacecraft to conduct complex maneuvers and make decisions without human intervention. In 2024, the first missions to study the atmospheres and climates of exoplanets were proposed, aiming to identify potentially habitable worlds beyond our solar system. The concept of space habitats expanded beyond traditional spacecraft and stations, with proposals for self-sustaining colonies in orbit around Earth and other celestial bodies. In 2024, the first missions to study the magnetospheres of gas giants, such as Jupiter and Saturn, were proposed, aiming to understand the dynamics of these powerful magnetic fields. Advances in materials science enabled the development of lightweight and durable spacecraft components, reducing the cost of space exploration and enabling longer duration missions. In 2024, the first missions to study the volcanic activity and geothermal features of icy moons, such as Io and Triton, were proposed, aiming to understand the processes shaping these dynamic worlds. The concept of space-based manufacturing gained traction, with proposals to build factories in orbit capable of producing goods in microgravity. In 2024, the first missions to study the origins and evolution of the solar system's small bodies, such as comets and asteroids, were proposed, aiming to unlock secrets about the early history of our cosmic neighborhood. Advances in quantum computing enabled faster and more efficient data processing for space missions, with applications ranging from navigation and communication to scientific analysis. In 2024, the first missions to study the potential for terraforming Mars were proposed, aiming to transform the red planet into a habitable world for a human settlement. The concept of space colonization gained traction, with proposals for self-sustaining colonies on the Moon, Mars, and beyond. In 2024, the first missions to study the geology and potential for resource extraction on asteroids were proposed, aiming to unlock the economic potential of these rocky remnants of the early solar system. Advances in biotechnology enabled the development of life support systems capable of sustaining human life in space for extended periods. In 2024, the first missions to study the dynamics of planetary rings, such as those around Saturn and Uranus, were proposed, aiming to understand the processes shaping these iconic features of the outer solar system. the concept of space tourism extended to destinations beyond Earth orbit, with proposals for trips to the Moon, Mars, and even asteroids. In 2024, the first missions to study the potential for extraterrestrial agriculture were proposed, aiming to develop sustainable food production systems for long-duration space missions and future colonies. Advances in nanotechnology enable the development of miniaturized spacecraft capable of exploring distant worlds and conducting complex scientific experiments. In 2024, the first missions to study the potential for terraforming Venus were proposed, aiming to transform the inhospitable planet into a habitable world for a human settlement. The concept of space-based astronomy expanded, with proposals for observatories in orbit around other planets and moons, offering new perspectives on the universe. In 2024, the first missions to study the potential for mining asteroids for valuable resources were proposed, aiming to unlock the economic potential of these rocky bodies. Advances in robotics enable the development of autonomous construction techniques for building habitats and infrastructure on other planets and moons. In 2024, the first missions to study the potential for generating power from nuclear fusion in space were proposed, aiming to provide a sustainable energy source for a future space exploration. The concept of space tourism extended to the realm of virtual reality, with proposals for immersive experiences that simulate the sensation of space travel. In 2024, the first missions to study the potential for generating power from nuclear fission in space were proposed, aiming to provide a reliable energy source for long-duration missions. Advances in neuroscience enabled the development of countermeasures to mitigate the effects of long-duration space travel on the human body. In 2024, the first missions to study the potential for manufacturing pharmaceuticals in space were proposed, aiming to take advantage of the unique microgravity environment for drug discovery and production. The concept of space-based agriculture gained traction, with proposals for growing crops in orbit and on other celestial bodies. In 2024, the first missions to study the potential for 3D printing habitats and infrastructure on other planets and moons were proposed, aiming to leverage local resources for construction. Advances in energy storage technology enabled the development of lightweight and efficient batteries for powering spacecraft and habitats. In 2024, the first missions to study the potential for using genetic engineering to enhance the resilience of crops in space were proposed, aiming to develop strains capable of thriving in extraterrestrial environments. The concept of space-based manufacturing expanded to include the production of advanced materials and electronics in microgravity. In 2024, the first missions to study the potential for using artificial intelligence to optimize space missions and operations were proposed, aiming to increase efficiency and reliability. Advances in telecommunication technology allowed faster and more reliable communication between Earth and spacecraft, enabling real-time control and data transmission. In 2024, the first missions to study the potential for using robotics and automation to construct habitats and infrastructure on other planets and moons were proposed, aiming to reduce the need for human labor in space. The concept of space-based tourism extended to include experiences such as spacewalks and zero-gravity flights. In 2024, the first missions to study the potential for using renewable energy sources, such as solar and wind power, in space were proposed, aiming to reduce reliance on traditional fuels. Advances in quantum communication enabled secure and unbreakable encryption for data transmitted between Earth and spacecraft. In 2024, the first missions to study the potential for using space-based resources, such as water and minerals, to sustain human colonies in space were proposed, aiming to establish self-sufficient outposts beyond Earth.